Hi, and welcome to this little tutorial on how to do acid-base imbalances, or arterial blood gases. Sorry, arterial blood gas problems. This is the way that I typically teach my students on campus, and so there are other methods out there, but this seems to work the best as my students pass on into the nursing program, and then they're able to do it really well. So I'm just going to go through step by step how to do this. You have all of the information in your quiz notes for week 8 or for quiz 8. You have all the information that you need. So if you follow along with that, if you print out all of that and then use it as you're going through the problems and as you watch this tutorial, then you should be able to do well on that portion of the test. So first thing is to know that in our bodies we need to have 3 values within homeostatic range, and those values are pH and PCO2 and bicarbonate levels. So our pH should be between 7.35 and 7.45. Our PCO2 levels should be between 35 and 45 millimeters of mercury, and our bicarbonate levels should be between 22 and 26 milliequivalents per liter. Anytime that we see values outside of those ranges, then we know that something's going on, and we're going to look for 4 things. First of all, we're going to look at the type of imbalance. Is it going to be an acidosis or an alkalosis? We're going to look at the cause of that metabolic imbalance, or that acid-base imbalance. Is it going to be a respiratory cause or a metabolic cause? And then we're going to look to see if the body is doing anything to compensate for that. Is it respiratory compensation or is it renal compensation? And then we're going to take a look at the degree of compensation. Was it not compensated at all? Was it uncompensated? Was it partial compensation or full compensation? All right, so if you go through the information that I provided to you, there's a step-by-step guide on how to do that. And so I'm just going to go through that without looking at that guide, however. So here is a problem that I'm going to go through and give you step-by-step instructions on how to do this. So the very first thing that's the easiest to do is has to do with arrows. Let me see if I can make these arrows work. Oh yeah, that's going to be perfect. Okay, all right, so let's put our arrows in a different color. Let's do them in green. Okay, so if we take a look at this first problem, you can see that this is below normal range, so we're going to put a down arrow like that. And then we take a look at the second one. PCO2 levels should be between 35 and 45, and that's high. And then we look at the bicarbonate levels, and that is 22 to 26, and that is also high. Okay, so now we're going to go to our first thing that we want to do is look to see, is it acidosis or alkalosis? Well, because the pH is below 35, then we know that this is going to be acidosis. Let me put that in a different color. So I'm just going to write that in. So it's below normal range. Okay, then the next step that we do is take a look at the PCO2 levels. And the reason why we look at PCO2 levels is because our breathing rate is the quickest thing that's going to change our pH. And so if we have something wrong with our breathing rate, that will throw us into an acid-base imbalance. And so we look at PCO2 levels, we look to see if they are outside of normal range. Well, they are. It's high. Now, what does that mean? In being high, it means that we are retaining CO2. We're not breathing, so we're hypoventilating. And as you should know by now, through going through the acid-base information, that if you retain CO2, it's going to combine with water in the presence of carbonic anhydrase and turn into an acid, turn into carbonic acid. And then it will dissociate into hydrogen ions and bicarbonate ions. And you know what? I'm going to type that formula out, right, or that equation out right now, just so we can see, talk about it as we go. So CO2 plus H2O, and is going to give us, okay, then we're going to go back to here, H2CO, CO3, and again, it's a reversible reaction, so we'll make that reversible there, and then we'll text and put H plus HCO3 minus. Okay, so there is our carbonic acid bicarbonate reaction. All right, so if it's high, then it means, let me draw a thing, then it means that we have more CO2 and we're forcing the reaction to the right, and this makes things acidic. And so we know that this is acidic. So if that's the case, then, oops, I'll just draw this in. Then it will be respiratory. So in other words, if I have high, oh, I know another thing I want to show you. If I have high CO2, then it's going to be a respiratory cause. Let's put over here acidosis, alkalosis. Okay. But if I have high PCO2, that makes me acidic, and this makes me alkaline, and then this is acidic. So you'll notice, and then alkaline, that we have low pH is acidic, low bicarbonate is acidic, high pH is alkalotic, high bicarbonate is alkalotic, but low PCO2 is alkalotic, high PCO2 is acidic. So notice our arrows, see how they're going in the same or in different directions? So that means it's a respiratory cause. So if this is low, it means it's acidic, and then if this is high, oh yeah, we look over here, a high PCO2 also means acidic. So this is respiratory acidosis, and don't worry, we'll do some more problems to get you into the hang of things. All right, so respiratory acidosis. So we've got a point here because we figured out the imbalance. We have a point here for the cause. So now we need to take a look at compensation. And there's a rule of thumb for compensation. It's either one or the other, respiratory or renal. If it's a respiratory cause, it will always be renal compensation. If it's a metabolic cause, it'll always be respiratory compensation. So because this is respiratory acidosis, we just know automatically that it is renal compensation. Okay, so there's another point. So then we're going to put that right here. Renal compensation. Okay, and now we need to know how much renal compensation. So in other words, are my kidneys doing a lot of work to fix the problem? Are they not doing very much work at all? Or have they completely restored my pH back to normal range? So that's when we look at the compensating value. So the PCO2 is the cause. So then the bicarb level is the compensating value, and it's going to be high. So if we think about what our body would be doing, if I'm in an acidosis state, I want to raise my pH. So how do I raise my pH back to 7.35? Well, I'm going to retain bicarbonate because bicarbonate raises pH. It accepts hydrogen ions and it raises our pH. So I would want my bicarb to be higher than normal if I'm if I'm compensating for an acidotic state or respiratory acidosis. And it is in this case. And here's just a little rule of thumb. If compensation is going on, then the cause arrow and the compensating arrow will go in the same direction. And all of that is in your notes too. Now, how do I decide if it's uncompensated, partial compensation, or full compensation? Well, if it were uncompensated, that means my kidneys would not be doing anything to fix the problem. And so that would be a case where the value, the arrow value, okay, so if it were just a straight line like that, then no change, it was within normal range, then I know that this would be uncompensated, okay? If it's high, then, well, if it's outside of range, then I need to decide what is my pH. So if it's outside of range, but my pH is still broken, then that's going to be partial compensation. But we're going to look at some cases where the pH is back to normal range, and so then it would be full compensation. And I'll show you how we do that here in just a minute. So if we take a look at this, we have the down arrow, we have up arrow, so it's respiratory acidosis. This is also elevated so that I know that it's renal compensation, and so it's going to be, and I'll just write it in right here, partial renal compensation, and there is my fourth point. Okay, so respiratory acidosis with partial renal compensation would give you the 4 possible points out of 4 for a question that you'll see on test number 5 and on this on the quiz. But you can earn a bonus. Okay, so the pathological cause is going to be our bonus. So what does that mean? If you look through the information that I have for you in this unit, this section, it'll have the causes. So metabolic acidosis, and then it'll say diabetic ketoacidosis, starvation, alcohol ingestion, whatever. So you have a variety of pathological problems that will cause our different acid-base imbalances. And so you need to pick one of those for your possible cause, so, or your pathological cause. So if you look at the list that for respiratory acidosis, it'll say COPD, okay, hypoventilation due to COPD. So what this means is that I am not breathing well, I am retaining CO2, so I'm hypoventilating. Now, you are not going to put hypoventilation as the answer. You are going to say, well, what disease state causes me to hypoventilate? Well, COPD, for example. Okay, so COPD. And that would give you another point. Okay, so then you can get 5 points out of 4 for these questions. So let me throw in another question here, another type, and give you an example of, all right, sorry, I keep getting interrupted and I keep pausing this. You'll probably be able to tell that's what I've been doing. So the next thing we want to do is look at another problem. So we're going to go ahead and go to a second problem, and I got to find one really quick that is, okay, let's do this one. Okay, so the pH in this case is 7.48. The PCO2 is 29 millimeters of mercury, and the bicarb HCO3 minus is 25 mil equivalents per liter. Okay. All right, so now let's just do what we did in the last time. And we are going to start with our pH. We can see our pH is high, so we're going to put an up arrow right here. I should do it in a different color. Oh, well. Yes, I will do it in a different color now. Okay, then our PCO2 is low, so we're going to put a down arrow. Okay, and in this case, we have no change. We're within normal range. So what does that mean? Well, first of all, we know that this is high, so it's going to be alkalosis. So I could have put a text box in there. Oh, why don't we do that? Okay, this is low. And if we take a look at low, yep, low means alkalosis and PCO2. So the arrows, and notice how the arrows were in opposite directions, down and up this way. Well, here is up and down. So that still means it's respiratory. And then we would look, because it's respiratory, that it would be renal compensation. But we can see that our bicarb level is unchanged, and so we're going to have uncompensated. So this would be uncompensated renal. Okay, or actually, I like it if you put it this way better, no compensation. So actually, I should put right here, let me just, and let's put no compensation. No, I'll just put no. No, partial, and full. Okay, so no compensation, but you have to put in here, let's make a little be-do, because I messed up. Okay, there we go. So no renal compensation on that question. And now, what is respiratory alkalosis? Well, if we go back to our equation here, and we see if retaining CO2 going to the right causes things to become acidic, well, what if we go the other direction? What if we take bicarbonate and add hydrogen ions to it and change it back into CO2 and water? Well, sure enough, any time that you get rid of the, whoops, I don't want to do that. Anytime that you get rid of hydrogen ions, that's going to make things alkalotic. So when we take and move it in this direction, then we know that this is going to be alkalosis, or alkaline. Okay, and that's going to be to hyperventilation. Is going to cause that. Okay, so there is no disease really that causes you to hyperventilate. There are some things like high elevation, maybe if you have pneumonia, maybe you've got, I don't know, if you look at that list, but really, if you're in respiratory alkalosis, then your pathological cause is hyperventilation. Okay, let's do one more. And then I'll leave it and then let you guys watch this. I'll probably come back and do another video again if I'm not satisfied with this one, which I probably am not, but anyway. Okay, so let's do a different color. Ink. Let's just do blue, and we're going to come over here and do a text box. And let's now do, let's do this one. Okay, so, do I want to do that? No, let me find one that let me just make it up, for heaven's sakes. I've been doing this long enough, I can make stuff up. Okay, so this is going to be 7 point, let's do that, 7.41. My PCO2 is going to be, let's make it 28. Oh no, that's not going to work. Let's make it 49. And then our bicarbs, we're going to make 30. Okay, so let's go into put our arrows in, and all right. So first of all, oh, look at our number. That, my friends, is within a normal range. But within the normal range, it's on what side of the normal range? Well, it's on the high side. So we're going to just put a little baby up. Oops, not that one. We're going to undo that. We're going to put a little baby up arrow. And usually I do a dotted arrow, but that's hard to do on here. So we're just going to do it just like that. Okay, so it's within normal range, but it's on the high side. All right, so now let's look at PCO2 levels. Oop, those are high, and bicarb is high. Okay, so we haven't had a problem like this where the pH was normal or that the pH and the PCO2 went in the same direction. So if they go in the same direction, this is not the cause. But first of all, we need to go back because I forgot. We have not said what is the cause. So if I have 7.41, it's within normal range, but it's on the high side. So I know that I just came out of alkalosis. Okay, so I'm going to put that it was alkalosis. Now, if I look at the second one, well, it's up pH and PCO2 is up so that it is not the cause. So if it's not going to be a respiratory cause, then it is a metabolic cause. Okay, and then we look at our value right here, and so we know that if it's a metabolic cause, then it's going to be respiratory compensation. But what kind of respiratory compensation? Well, what I did, I was in an alkalosis state, so my pH was high. I held my breath. I retained CO2 to help bring my numbers back down again, and I at least got it back down to normal range. Now, I still have an issue. I still have something wrong with me, and I'll talk about that in just a minute. But at least my breathing rate has changed, that now I'm holding my breath more so that my pH is going to drop. So that means I have fully compensated my metabolic alkalosis through respiration. So I would call this metabolic alkalosis with full respiratory compensation. Now, again, because I was outside of normal range, because these numbers are not normal. So anytime I get any of these numbers wrong, then that means there's something wrong with me. So this one's fine, but these two numbers are still out of whack. So I've been put back into pH range, but I'm still sick. So there's still something wrong with me. So let's go to what are some metabolic causes of alkalosis. Well, if I'm in alkalosis, it means I've lost hydrogen ions. Well, what would cause me to lose hydrogen ions? Well, if I have lots of hydrogen ions in my stomach. So if I were throwing up just constantly, I was losing a lot of stomach acid, that would make my pH rise, and I would be in metabolic alkalosis. Another way for me to be in alkalosis is if I have too much bicarbonate. So that means I'm retaining bicarbonate, or I added more bicarbonate to me. So there's two ways that can happen. If I retained too many bicarbonates, they're going to be present in my digestive tract, because we know that as your stomach acid, the chyme goes into the duodenum, that your pancreas dumps a lot of bicarbonate into your duodenum, and then it goes on through your small and large intestine, and it gets reabsorbed. But what if you keep the undigested material in your digestive tract for a long time? Then that means I'm going to reabsorb more bicarbonate than I should. And in that case, how do we keep stuff a long time in our digestive tract? Well, we're constipated. So constipation is also going to cause us to have metabolic alkalosis. Or there's one other way to get too many bicarbs, and that's if we have an upset stomach and we eat too many Tums, because that's the active ingredient in Tums or Rolaids or Pepto-Bismol or whatever, to try to neutralize the acid. If I'm eating too many Tums, then that also is going to put me into metabolic alkalosis. So my pathological cause for this, I'm just going to go and put too many Tums, or constipation, or vomiting. Oops. Okay. So there is how to do each one of the different kinds of acid-base problems. So what I would like you to do in the questions, the problems that I gave you, is go ahead and work on them and see how they fit into these three different kinds that you can have as far as compensation is concerned. So partial renal compensation, no compensation, or full compensation. So remember, acidosis, pH is low, below 7.35. Alkalosis, pH is above 7.45. Respiratory cause is if the PCO2 is in an acidosis state is above 45, or in an alkalosis state if it's below 35. If it's going to be a metabolic cause, then if you're acidosis, then your milliequivalent or your bicarbonate is going to be lower than 22. If it's an alkalosis state, then it's going to be higher than 26. Then your compensation. If it's a respiratory cause, it will always be a renal compensation. If it's a metabolic cause, it'll always be a respiratory compensation. And then how much compensation is there? If there's no compensation, then the other value, the compensating value, whether it's CO2 or bicarb, will be unchanged. If it's partial, all three numbers will be out of range. And then if it's full, the pH will be in normal range, but the other two values will be out. So here's our no compensation. You can see the compensating value is within a normal range. All right, I hope this helps because this is a difficult thing to do without having me show you in person. And but there's a lot of YouTube videos, but again, they're going to do it differently. And this is exactly how I grade you. This shows you what points I give or what things I give you points for. So again, you'll have a point for the type of imbalance, you'll have a point for the cause, you'll have a point for the type of compensation, and then a point for the degree of compensation. So 4 points out of 4, and then you'll get 1 bonus point for telling me what's wrong with you. How sick are you? You're sick with what kind of problem? All right, so that's all for now.